Good day to everyone. I hope all is well. I hope your activities for the past week did not drain all of your brain cells. So, for today, let's already continue with our lessons for the finals. Time is so fast, so we're already halfway through for your crash course in pre-calculus. And we now enter module 3. Module 3 will be on solid mensuration. We have several units for this uh, unit. So when we say solid mensuration, we are after measurements of solids. And to begin with, before we consider measurements of solids, let's review measurements of plane figures. So these things are quite familiar to you already. And to begin with, we look at some plane figures wherein we consider their areas. And when you were in elementary, the simplest way to remember an area is looking at how many squares you can put on the figure. Okay? So when we talk about area, it will always be in terms of square units. And we have the following uh, formula. So for the square, of course, we consider the definition of a square. It's a polygon wherein we have four equal sides and we have two adjacent sides will always be perpendicular with each other. And each side is called an edge. So area is just the square of the edge. So if the edge is A, then the area is just A squared. So for the rectangle, we have one side is longer than the other. And for this one, we can call the this side as the length, if you like. We can also call this as the width. So area can be length times width, or if it will be labeled in another way. So in this case, the length was labeled as base, the width was labeled as altitude. So area is still equal to the length times the width, or that's the base times the altitude. And then for the right triangle, of course, a triangle is a polygon wherein we have three sides. And one property of a right triangle is that we have one 90-degree angle, or we have one right angle. So the side opposite the 90-degree angle is the hypotenuse, while uh, these sides here are called the legs. And the area for this right triangle is 1/2 base times altitude, or 1/2 base times height, wherein the base and the height for a right triangle will be the legs. So we have for this figure, the area is 1/2 b times a, since b and a are the legs of the right triangle. And then uh, if we want now to compute for the sides, we have what we call our Pythagorean theorem. So Pythagorean theorem, remember, will only work for right triangles, wherein the Pythagorean theorem is given by the square of the hypotenuse is equal to the sum of the squares of the legs. And then when we consider now the area of an oblique triangle, so an oblique triangle is a triangle that is not a right triangle. So an oblique triangle, we can always find a height or an altitude. An altitude or a height is always obtained by drawing a perpendicular line coming from one vertex to its opposite. So it may happen that your triangle will now look something like this. So if you will consider the altitude coming from, let's say, this vertex here, then you have to drop a perpendicular line. So you have to extend this. This will now serve as the altitude or the height, and then this will now serve as the base. So area, you're familiar with this. It's 1/2 base times height. So for this first figure, this is your base, this is now your height. And for this type of triangle, this is your base, and this is now the height. Also, there is a shortcut for if you don't like to use the formula 1/2 base times height for a triangle, you can also use what we call the Heron's formula. And the Heron's formula is given by area is the square root of S times S minus A times S minus B times S minus C, where S, so this is very important, where S is just equal to the sum of the sides divided by. Okay, so whatever value we get for S, we just substitute those or the value of S in this formula. We will be using the formula later on as we apply. Then we have the parallelogram. Parallelogram is a quadrilateral wherein we have two pairs of parallel sides. Kaya nga tinawag na parallelogram. So we have two pairs of parallel sides. So if we want to get now the area, we can get one of the parallel sides. We call that as the base. And then if we now consider the uh, distance between the two parallel sides, kung alin yung consider natin na base, that will now be called as the height. So meaning, pwede rin pabaliktad yung pagkuha natin. Itong kunin natin na base. And then just get the perpendicular distance between the two sides that will now be your height. And the next formula is if you have a quadrilateral, a four-sided polygon inscribed in a circle. So pag sinabing inscribe, each corner or vertex of the polygon is touching the circle. And the formula for this one is called the Brahmagupta's formula. And it is equal to the area. Area is equal to the square root of S minus A times S minus B times S minus C times S minus D, where A, B, C, D are the sides of the quadrilateral. So we can label it as A, B, C, and D. So S is A, B, C, D all over 2. So somewhat similar to the Heron's formula. Then next is the trapezoid. Trapezoid is a quadrilateral wherein we have a pair of parallel sides and then we have a pair of non-parallel sides. The parallel sides are called the bases. Okay, the parallel sides are called the bases. And then when we take again the distance between our parallel sides, of course, that will always be the perpendicular distance. That will now be considered or called as the height. And the area of a trapezoid is given by 1/2 the sum of the bases multiplied by that. So you just get A and B. So those are the bases. You just add them multiplied by the altitude times 1/2. And then the regular polygon is given by the formula. Area is 1/2 the apothem times the perimeter. So what's the perimeter again? Perimeter is the uh, sum of the sides. And then when you say regular polygon, the length of each side or the lengths of the sides are all equal. Okay, regular polygon. And then what's an apothem? An apothem actually is if we now try to inscribe this polygon in a circle, okay, uh, you form here an isosceles triangle actually. So if you now a regular polygon can always be divided into equal isosceles triangles. So pag meron tayong six-sided regular polygon, we have uh, six isosceles triangles. Anyway, if you don't want to consider the circle that circumscribes this polygon, just get one isosceles triangle. If you get the perpendicular distance from the center of the polygon to the perpendicular distance to each side of the polygon, that will now be called the apothem. Or another way of getting the area is you can get the area of one right triangle or one isosceles triangle, I mean. can isolate one isosceles triangle, get the area of that using the formula 1/2 base times height, and then multiply it by the number of sides of the regular polygon. So in this case, since we have a six-sided polygon, then we get the area of one triangle times 6. Next is for the circle. Circle, we have the circumference. Circumference, when we talk about the circumference, it's like the uh, perimeter. So circumference is 2 pi r, where r is the radius, or 2 pi, or pi d, because d is the diameter and diameter is 2 times r. So this is also your radius r, and this whole thing here is the diameter. So circumference is pi d. While for the area, it is given by pi r squared. Or if you would like to use the diameter, it will now be pi over 4 times diameter squared. Again, with the relationship that the diameter is 2 times the radius. And then we have the sector of a circle. A sector of a circle is like, if you will imagine a pizza, one slice of a pizza is a sector. And here we have some things to consider. So if we now take this as the sector, so we have here our angle theta, and then we have the radius r, and then we have our, uh, so we now call this as the arc. The theta is called the arc. So area is 1/2 times the radius r times the arc c. Okay, the arc is, anyway, these two are proportionate with each other, but we need to take note here that uh, our theta is always in regions. Okay, in regions. But if you like to convert the formula in degrees, just convert your angle uh, theta in degrees, which will now give us the formula. Area is theta over 360 pi r squared. And then for the segment of the circle, the sector is the slice of the pizza. The segment is this small part here. So, kung yung sa pizza, yan yung dulo ng crust. Okay? So, segment. So, standard formula for that is just get the area of the sector minus the area of this triangle. And then for the ellipse, area is pi AB. So, actually, and technically, for the ellipse, this is called the center. This portion here, it's called the center. This is actually, if you try to connect this line segment form is called the major axis. This line form here is called the minor axis. So, from the center to an end of the major axis, that's called A. And then from center to an end of the minor axis, that's called B. Anyway, we will elaborate more on this when we get to analytic geometry. So area is given by pi AB. Okay? So I'll be trying to solve some problems here, which are already in your module. So let me just explain some of the problems that I have chosen to discuss. I will not give the complete solution, but I'll just give the analysis. But what I mean by complete solution is the computation part. You can just do the computation part, or you can just refer to your notes if you'd like to see the computation of this. But I would like to give the analysis of the problems instead. So we have this problem. A beach tent is designed so that one side is open. Find the number of square feet of canvas needed to make the tent. So if this is the tent, this front section here is an open section. Okay. This front section here is an open section. Okay. Therefore, if we want now to get the total canvas needed, sabi rito, square feet. So we are after the total area of the surfaces that we have. Siyempre, yung dito sa baba, hindi naman na natin lalagyan yan kasi that's the ground, okay? Therefore, if we will now take a look at this figure, then if we want now to get the total area, if you like to represent this as 80, we have here a rectangle, okay? So that area of that rectangle, maybe we can call it rectangle 1, plus we can get this rectangle here, we can label that as 2, area of rectangle 2, and then plus we now consider the sides. What shape do we have there? We have two sides parallel with each other, and then we have two non-parallel sides. So that's a trapezoid. So area of trapezoid. Okay, area of trapezoid. So this is our trapezoid. But there are two trapezoids there, so we multiply this by. Okay, so going further, area of this rectangle will be length times width. So this length is given by 12. Okay, so that will simply be 12 feet by this 6 feet. 12 feet times 6 feet plus area of this rectangle here. We have 12 by, we don't know yet this length here. We don't know yet this length here. So let's call that as, let's say, L, L1 or L. Okay, so that will be area is base, that's 12. 12 feet multiplied by L. And then for the trapezoid, what's the formula for a trapezoid? Sum of the bases, 1/2 times sum of the bases times the height. So this is obviously a 90-degree angle. Therefore, 6 will serve already as the height. 6 feet is one of the bases, and 8 feet is the other base. Therefore, this will be 2 times 1/2 the sum of the bases. So what's one base? 6 feet plus the other base, that's 8 feet, multiplied by the height, which is 6 feet. Okay, there you go. So we can already actually compute for the value of this. We already have the value of this ready to be computed. So what's missing? This is missing. So how do we now get the value of L? If we will get the value of L, we can actually draw a perpendicular line there. And what do we have? We now obtain a right triangle. That's L. This will be 6. Okay. If this is 8 and this is 6, that must be 2. Okay. Therefore, to solve for L by Pythagorean theorem, L squared is L squared is, let me just fix that. So L squared will be 6 squared plus 2 squared. Or simply, L is the square root of 6 squared plus 2 squared. So if we now have the value of L here, we'll just compute that value of L and then just insert the value here. Substitute the value, then add all the values together. You will now have your total area. So again, the value is in your module. You can double check the value in your module. Again, the important thing here is we have considered the analysis. Next problem. Again, this is in your module. So we have find the exact area of the shaded region. So we have this as the shaded region. So in our figure, we have a circle and then we have a rectangle. So if you will consider the shaded region, we can call that as area A. It will simply be equal to what? We can get the area of the circle minus the area of the rectangle. And area of the circle is pi r squared. So we now draw a line there from center. So that will now be our r, pi r squared. But r is not yet given. But if we will now take an analysis, how do we compute for r? So we can form a right triangle here, if you like. This will simply be half of 6 because it's a rectangle. This will be 3. This will be half of 8. That will be 4. Therefore, r by the Pythagorean theorem is the square root of, or we can, I think, just use r squared. R squared na lang. By Pythagorean theorem, r squared is 4 squared plus 3 squared. So that's the value of r squared, which means area of triangle by formula is pi r squared. That's the reason why I did not consider the square root anymore. Anyway, our formula for the area is pi r squared. So after computing r squared here, that's 16 plus 9. Therefore, r squared will be 25, or r is 5. But anyway, again, we need r squared here. So this is pi times 25. And then minus area of the rectangle. Area of rectangle is length times width or base times height. So that will now be 8 feet times 6 feet. So this is square feet then, no? That's square feet, and then this is also square feet. 6 times 8 is 48. Then you can already find the total area by computing that value. Next example. In the next example, we have this figure. Again, we are after the area of this shaded region. This shaded region. Analysis will tell us that if we want to get the total area, we have the area of the triangle, this whole area here, minus, how do we get this three things here? The area of those three sections. Each section is actually a sector, right? It's a sector. Therefore, there are three sectors there. We can get the area of the circular sector times 3. Okay, so by formula, so if you like to deal with this separately, area of triangle is, you can use 1/2 base times height, but if you will use 1/2 base times height, this is an isosceles. This is an equilateral triangle, which is also an isosceles triangle. So you can have this, okay, 1/2 base, but you still need to compute for this one. It's not yet given, but you can compute that. That will be 5, that will be 10. So you can compute this by the Pythagorean theorem. That's one option. Or you can use the Heron's formula. And again, the Heron's formula, if you like to review the Heron's formula, the Heron's formula is given by S times S minus A times S minus B times S minus C, where S is A, B, C divided by 2. So you can use that. So if you like to get the formula of the triangle, you can use the Heron's formula. This is the square root of S times S minus A times S minus B times S minus C, where S is A plus B plus C divided by 2. But A, B, and C are equal, so this is 10 plus 10 plus 10 divided by 2. That's 30 divided by 2. Your S is 15. Therefore, area of triangle will be S is 15. This is S minus A. Isn't it that A, B, and C are equal? 10 each yan eh. So pare-pareho lang yung value niyan. So S is 15. So that's 15 minus 10 times 15 minus 10. Or you can just have that as times 3. Okay na ba times 3? Kasi di ba pare-pareho yung value nito. So that's 15 minus 10 times 15 minus 10 times 15 minus 10. Or 15 minus 10 times 3. Kasi 5, sorry. So that will be, that should be cube. Please forgive me for that. That should be, oops. So we now have, so if to avoid that confusion, sorry, forgive me for that. That will be 15 times 15 minus 10 times 15 minus 10 times 15 minus 10. That should not be times 3 but cube. So that will be the square root of 15 times 5 times 5 times 5. That's 5 cubed. Anyway, just give the computed value for this area of a triangle. And then for the area of the sector is, if you will go back to our formula, area of sector is given by, where is that formula? There you go. Area of sector is 1/2 r squared, 1/2 r squared theta. R is theta. R squared is r is the radius. Theta is the central angle in radians. Okay. Or if you like to use this, pwede rin naman. Pwede rin naman ito yung gagamitin natin. It's uh, pi over 360. And what will now be your area here? It's 1/2. Area of sector is 1/2 r squared theta, where theta will be this angle here, and then this will now be your r. And what's your r? R will be, since this is an equilateral triangle, this will now be r is 5 centimeters. Theta, this is in degrees. In degrees lang muna para makita nyo. 60 degrees. Okay, 60 degrees. Why 60 degrees? This is an equilateral triangle. An equilateral triangle is also equiangular. Therefore, since this is in degrees, if you want to use directly this formula, remember theta here must be in radians. Okay, so again, since I don't like to make the solution of this very long and the discussion very long, just refer to your module, just inject the values of the respective areas here. Area of triangle, then the area of the sector. The area of the sector, the computation is also given in your module, and then the area of the triangle is already available here. Okay, so that's for the area of the plane surface. So please just go over again the solutions of the other problems in your module and work with the problems also given there as your practice problems or your homework. Good day again to everybody.